नमस्कार। ऑनलाइन क्लासेस में एक बार आपका पुनः स्वागत है। लास्ट क्लास में हमने ट्रिग्नोमेट्रिक रेशियोज में देखा था कि सबसे पहले ट्रिग्नोमेट्रिक इससे क्या मतलब निकलेगा, इसका क्या मीनिंग होगा इसका, और हमने देखा था ट्रिग्नोमेट्रिक को यदि 3 पार्ट्स में डिवाइड कर दिया जाए, TRI ट्राई मीन्स 3, Cono means sides and metric means measurement. Then what we can get by this word? We can get any measurement of 3 sides. And as we know that the figure which has 3 sides is called triangle. In the condition of triangle, the second thing we know that this figure means triangle is 2D shape. What is 2D? What do you know by 2D? 2D means the system which has 2 dimensions. The 2 dimensions are x and y, or y and z, or z and x. It means we can get any 2 sides respectively. That's why this system is called 2D system. And the figure like triangle, like circle, and like parallelogram, rectangle, etc. These are the figures of 2D system. अगर हम बात करें ट्राइंगल की, तो ट्राइंगल में हम जानते हैं कि हमें कितने साइड्स की आवश्यकता है? 3 साइड्स की आवश्यकता है। और 3 साइड्स की जब बात करते हैं तो सबसे पहले हम एक बेसिक ट्राइंगल, राइट एंगल ट्राइंगल की बात करते हैं। उस राइट एंगल ट्राइंगल के लिए हम जानते हैं, यदि मैं एक राइट एंगल ट्राइंगल कंस्ट्रक्ट करूं, this is right angle triangle. In the early classes we have studied about right angle triangle somewhere, where the side in front of 90-degree angle is called hypotenuse. Means this side is called hypotenuse. The side, if we are taking an angle, if I am assuming that the angle is constructed at the point A, then the side in front of the angle theta is called perpendicular. Then for this angle theta, this side is called perpendicular, and the remaining other third side is called base. Then this one is called base. By assuming theta and 90-degree, all 3 sides we have measured in terms of hypotenuse, perpendicular, and base. Depending on these 3 sides, we get 6 types of trigonometric ratios. What are the trigonometric ratios? We note down, we can write all trigonometric ratios like as first one is sin theta, second one is trigonometric ratios. Sin theta, cos theta, tan theta, cot theta, sec theta, and cosec theta. These are of trigonometric ratios. Then first we will find the relation. Then it means how we can find any trigonometric ratios in the terms of 3 sides, means hypotenuse, perpendicular, and base. What I am saying, मैं कह रहा हूँ कि यहाँ पे जो ट्रिग्नोमेट्रिक रेशियोज है वो टोटल 6 टाइप्स होते हैं। कौन कौन से? साइन होता है, कोस होता है, टेन होता है, कोट होता है, सेक होता है और कोसेक होता है। और इन इन सभी ट्रिग्नोमेट्रिक रेशियोज को हम जो थ्री साइड्स हमने पढ़ी है कौन कौन सी, हाइपोटेन्यूज, बेस एंड परपेंडिकुलर, इनकी टर्म्स में इसको ज्ञात करने की कोशिश करते हैं। तो एक रूल है, उसके माध्यम से जो शुरू के तीन ट्रिग्नोमेट्रिक रेशियोज है वो हम फाइंड आउट कर लेते हैं। व्हाट इज द रूल? वी कैन राइट sin, cos theta and tan theta in the terms of, first one is perpendicular P upon H, second one is base upon H, and third one is perpendicular upon base, P B P upon H H B. The first one will represent sin theta, second one will represent cos theta, and third one is represents tan theta. Then we can get by this relation sin theta is equal to P upon H, cos theta is equal to B upon H, and third one is tan theta is equal to P upon B. All the three relations we have to remember. And the other remaining three parts means cot theta, sec theta and cosec theta can be obtained by oppositing respectively. Means if we are talking about cot theta, then cot theta will be opposite of tan theta respectively. This one is opposite of tan theta, this one is opposite of cos theta, and this one is opposite of sin theta. It means we can find other remaining three parts. First one is cot theta. Then I am saying cot theta is the opposite function, opposite trigonometric ratio of tan theta. It means I can write cot theta is equal to 1 upon tan theta. From here one relation is obtained. What is the relation? If I multiply cot theta into tan theta, then the result will be 1. This is the relation obtained from this one. And if I am finding cot theta in terms of three sides, then the result will be cot theta is equal to cot theta is equal to, make opposite of tan theta, then the result will be, if I am seeing here, then tan theta is equal to P upon B. Okay, then the cot theta will be opposite of P upon B means B upon P. This is the relation of cot theta. The next one, sec theta. Sec theta is the opposite function of cos theta. Here I can see clearly. If I want to find sec theta, the value of sec theta, then I have to make opposite of cos theta. Then it means sec theta is equal to 1 upon cos theta. Clear? Then relation from here we can get sec theta dot cos theta is equal to 1. The next relation is obtained like this. And from here, if I want to find sec theta in terms of three sides, then the value will be obtained as sec theta is equal to 1 upon cos theta. What is the value of cos theta? From here I can see directly cos theta is equal to B upon H. Then the value of sec theta will be H upon B. This is the next relation. In the next and last condition, last but not least, cosec theta. Cosec theta, we know cosec theta will be opposite of sin theta. Then I can write 1 upon sin theta. And from here the relation will be obtained as cosec theta dot sin theta is equal to 1. The next relation is obtained. And if I want to find cosec theta in terms of sides, then cosec theta will be opposite of sin theta, and thus the value of sin theta will be P upon H. Then cosec theta will be H upon P. Then I can write all the trigonometric ratios together. But we can say sin theta is equal to P upon H, cos theta is equal to B upon H, and tan theta is equal to P upon B. From here cosec theta I can write along with the opposite function of sin theta is H upon P. Here I can write sec theta is equal to one is H cot theta, and cot theta is equal to B upon P. All these six functions, all these six trigonometric ratios are written here. You can note down. Okay, in the next condition, we will find trigonometric ratios at different type of angles. What is different type of angles? If I am taking theta, the value of theta, and if I vary the values of theta from 0 degree to 90 degree, then what is the effect on three sides? अगर मैं थ्री साइड्स में थीटा की वैल्यू पे डिपेंड करते हुए देखूं कि थीटा को यदि वेरी किया जाता है 0 डिग्री से 90 डिग्री की तरफ, तो उस कंडीशन में जो ये ट्रिग्नोमेट्रिक रेशियोज है इनकी वैल्यू क्या होंगी. ओके, देन फर्स्ट वी विल हैव टू स्टडी अबाउट द ट्रायंगल व्हिच हैज 0 डिग्री एंगल. एंड 0 डिग्री एंगल इट मींस दिस साइड्स hypotenuse. In the condition of 0 degree, hypotenuse will tend to AB. It means if I am moving theta towards 0, then this point C will tend to B. Okay, then I am removing first. Okay, in the first condition is taken for 0 degree angle. Okay, trigonometric ratios for angle 0 degree. First I am taking the value of theta is 0 degree. Then what we can get by this point, by this sentence 0 degree, it means if I prepare any diagram, and if I am taking the point C here, this is the intersection point of both the lines, and this is the point of X. First I have to put a perpendicular to base, then this angle will be 90 degree. Okay, in this condition this will be H, for this angle theta this will be P, and this will be B. If I am moving theta tends to 0, you can see directly here what I am doing here. I am just making theta tends to 0, means this angle will be 0, and in the condition of angle will be 0, if I am moving, you can see directly here, if I am taking this side the base and this side is hypotenuse. If I have to make the angle 0 degree, then I have to move like this side, from this side. If I am moving from this side, then this hypotenuse will move towards base, and in the final situation this point will move towards this point. It means this distance is moving towards 0. Then if I am making theta tends to 0, then in the condition AC, this point we can assume B point. Okay, B point. Or if we want to be here base B point, then we can assume it D point. No problem. Then AC will move towards AD, and in this condition CD tends to 0. It means this is hypotenuse. You can see here in this condition. Okay, this is hypotenuse, this is base, and this is perpendicular. And all the relations we have get, then the then the obtained result of trigonometric ratios in terms of sides, then we can get as sine theta. First we have to find the value of sine theta. Sine theta will be, you can know, or you can see here what is the value of sine theta. We know what is the value of sine theta, perpendicular upon hypotenuse. It means P upon H. Then what is the value of P? P is equal to CD. Then this is the CD and this is H. H means AC. Okay, in this condition, if I am taking theta is equal to 0 degree, then sine 0 degree is equal to, sine 0 degree means the value of CD when theta moves towards 0 degree, then CD is moving towards 0, then the value of CD will be 0 and the value of AC is equal to AD. And if I divide 0 by any non-zero value, then the result will be 0. Then I can see here sine 0 degree is equal to 0. This is the condition when I make theta is equal to 0 degree. The next trigonometric ratio is cos theta, and we know the value of cos theta is equal to base upon hypotenuse. Okay, I can write B base upon hypotenuse. What is the value of base? It is AD. Then the value will be AD upon, what is the value of hypotenuse? It is AC. In the condition when I make theta tends to 0, it means if I put the value of theta is equal to 0, then the obtained result will be cos 0 degree. And cos 0 means what is the value of B? B is equal to AD. Okay, right? And in the condition when theta is moving towards 0, then AC is also moving towards AD. Then in this condition AC will also AD, and we know AD is equal to AD. Then both are cancelled. The result, obtained result is 1. Then we can say that here cos 0 degree is equal to 1. This is the second condition. In the third condition, we will get tan theta. And what is the value of tan theta? Tan theta is given by perpendicular upon base. Then perpendicular upon base. What is the perpendicular? We can see here in this diagram, perpendicular is given by CD. Then the value of perpendicular will be CD upon, what is the value of base? It is equal to AD. Then CD upon AD. In the condition when I am moving theta towards 0 degree, then tan 0 will be, tan 0 degree will be, okay. Let us see about what is the value of CD when I am moving theta towards 0 degree. You can see here CD is tending to 0. It means it will be 0 upon AD, and the obtained value will be 0. Then I can see here कि tan 0, what is the value of tan 0 degree is equal to 0. Okay, I have got all three trigonometric ratios. The rest or remaining trigonometric ratios can be obtained in terms of these three obtained trigonometric ratios. How? First, I have to find out the value of cos 0 degree. As we have discussed, as we have studied about the relation of tan theta and cot theta, and we have to remember about the result of cot theta and tan theta. As we know, cot theta is the opposite trigonometric ratio of tan theta. It means I can write cos 0 degree is equal to 1 upon tan 0 degree. Then the value will be obtained as 1 upon tan 0. Tan 0 is equal to 0. Then the value will be infinite. You have to remember this one. How we are getting infinite? It is said that if we divide in the algebra, if we divide any non-zero value by 0, मतलब जब किसी अशून्य संख्या में किसी शून्य का भाग यानी कि शून्य का भाग दिया जाए तो उस स्थिति में जो वैल्यू ऑब्टेन होती है वो हमेशा इनफाइनाइट होती है। ठीक है, चलिए बात करते हैं। तो इसका मान आ गया हमारे पास कितना, cos 0 degree is equal to infinite. In the next condition we will find the value of sec 0 degree. As we know, sec 0 degree is the opposite of cos 0 degree. Okay, then the obtained value will be 1 upon, what is the value of cos 0 degree? It is equal to 1. Then 1 by 1 we know 1. Then sec 0 degree is 1. The last one, cosec 0. As we have studied earlier, what is the relation of cosec theta and sin theta? And we know cosec theta is the opposite trigonometric ratio of sin theta. Then I can write cosec 0 is equal to 1 upon sin 0. And the obtained value will be 1 upon again 1 upon 0, and it is defined by infinite. Okay, in this condition cosec 0 degree is equal to infinite. All six trigonometric ratios we have obtained, and we can write all these six trigonometric ratios together. How can I write? Okay, first write down. Okay, in this condition I'm writing here all the results together. First one is sin 0 degree. Sin 0 degree is equal to 0. Next one is cos 0 degree is equal to 1. Next one is tan 0 degree is equal to 0. In the next line, here I can write the opposite function respectively. What is the opposite of sine? We know cosec. Then cosec 0 degree is equal to infinite. What is the opposite of cos 0? It means sec. Sec 0 degree is equal to 1. And what is the opposite of tan 0 degree? It is cot 0 degree, and the result will be infinite. We can see directly from here. In the next condition, we will study about trigonometric ratio when I am making angle towards 90 degree. If I am taking angle as 90 degree, then what is the effect or what is the value of trigonometric ratios? Then the second point will be trigonometric ratios. Trigonometric ratios for angle 90 degree. Okay, in this condition we have to study about the value of theta, as I am making the value of theta towards, I am moving the value of theta towards 90 degree. And in this condition we can see if I am making theta tends to 90 degree. Let us see here. Okay, first I have to prepare this triangle again. The triangle is given as, this is the point X. This is the point X. The intersecting point is given by A, and this point is C. Okay, I am making a perpendicular by the point C to line AX. And the intersecting of perpendicular to this line is D. Here I am writing B. but here I am taking as D because we have to note down these sides in terms of perpendicular, hypotenuse and base. Okay, if I am taking this angle 90 degree, then in this condition this will be hypotenuse, this will be, if I am taking angle as theta, then the sides in front of theta is taken as perpendicular and the remaining third side is base. This is the base. Okay, let us see here what is the effect if I am moving theta towards 90 degree. अब मैं एंगल को किसकी तरफ मूव करा रहा हूँ, 90 डिग्री की तरफ, तो उस कंडीशन में क्या इफेक्ट आएगा यहाँ पे वो हमें देखना है. चलिए देखिए, ध्यान दीजिए. First see here, if angle is okay, in this condition first this line is coincident on this line, it means both the lines are coincident, it means in this condition. If I am taking as this situation and if I am moving this line towards 90 degree, if I am moving this line towards 90 degree perpendicular, then the condition will be obtained like this. In this condition we can see the hypotenuse, this one, the hypotenuse somewhere theta will obtain, and if I am moving continuously, then the next figure will be, the figure is shown as here. Okay, first one is, this is X, this is A point, this is C point, and the perpendicular intersecting at D point. Okay, first I am moving this side to make an angle at 90 degree, then this sides will move towards perpendicular, it means it is given for here and the perpendicular will be here, you can see, and this point is D dash and this point is C dash. Okay, from this condition we can see if I am moving the angle, this angle towards 90 degree. Okay, in this condition you can see C dash is moving towards this side and D dash is coming towards A. Okay, it means the condition is given like this. This point is coming towards A. Okay, and the distance is distance AD is decreasing, you can see from here. In the next condition, if I am taking as this side, the next point will be D double dash and this one is C double dash. From here you can see, first if I take theta here, then I am increasing theta for different values. If I am increasing, then from this situation I can see clearly from here that this distance is coming towards, this point D is coming towards this point. It means this distance is decreasing continuously. Okay, then again this distance is less than by this distance. First we can write AD dash is less than AD, or in the second condition we can write AD is greater than AD dash. In third condition AD dash is greater than AD double dash. Or in the final situation, if I prepare that if this sides, it means this hypotenuse completely move towards perpendicular, means prepare diagram like this. Okay, in this condition you can see this point is coming towards A, and in the final situation when theta take the value at 90 degree, then distance will be, it means theta is equal to 90 degree at, we can see at theta is equal to 90 degree, the value of AD tends to 0. Okay, and then the next condition, what is this point and AC, this one towards CD, means in the final situation this point is coming here, that's why this one will prepared by perpendicular and this one is base. Okay, all the values we can obtain by these relations at 90 degree. Then the first result will be sine 90. Okay, sine theta is given by, we can see sine theta will be obtained by perpendicular by h. It means p upon h. It means p is given by CD. Okay, and h is given by AC. And if I am taking theta as 90 degree, okay, in this condition the angle will be sine 90 degree is given as CD. Okay, CD upon AC, and the value of AC is also moving towards CD. In the final situation the AC will also CD, then the value obtained will 1. In this condition I can write sine 90 degree is equal to 1. The next trigonometric ratio given by cos theta, then cos theta is equal to, we know cos theta is equal to, you can see from this diagram, base upon hypotenuse. It means base upon hypotenuse. What is the value of base? You can see the base is given by AD. Then the value will be AD upon, what is the value of AC? Sorry, hypotenuse, it is AC. If I am making the value of theta is equal to 90 degree, then cos 90 will be, okay. First see, if I am taking theta is equal to 90 degree, then AD is moving towards 0. It means the value of AD is equal to 0 upon AC. And what is AC? It is CD. Then the obtained value will be 0. In this condition, cos 90 degree is, this is the second condition. Third condition, I am talking about the value of tan theta. Okay, tan theta, you can see from this diagram, what is the value of tan theta? It is perpendicular upon base. Then I can write perpendicular upon base. What is the value of perpendicular? It is equal to CD. Then I can write P is equal to CD. Then base is equal to AD. Okay, if I take the value of theta is equal to 90 degree, then tan 90 degree is equal to CD. And CD, you can see, CD is equal to, AD. What is the value of AD? AD is moving towards 0. Then CD upon 0. It means we can, if we divide any non-zero value by 0, then we will obtain infinite. Then the value will be tan 90 degree is equal to infinite. This is the third condition. And the remaining 3 trigonometric ratios we can directly get in terms of all these 3 trigonometric ratios. Okay, next one, I want to get cot 90 degree. And we know cot theta is the opposite trigonometric ratios of tan theta. Then we can write tan 1 upon tan 90. What is the value of tan 90? It is infinite. Then if we opposite infinite, then the obtained value will be 0. It means cot 90 is equal to 0. Next trigonometric ratio, sec 90, and the sec 90 is the opposite of cos 90. Then I can write 1 upon cos 90. It means 1 upon cos 90. What is the value of cos 90? We can see cos 90 is equal to 0, and 1 upon 0 we know it is infinite. In the next condition, we can write sec 90 is equal to infinite. In the next condition, if we get cosec 90, cosec 90 is given as 1 upon sin 90. And what is the value of sin 90? It is equal to 1. It means 1 divided by 1 is equal to 1. It means cosec 90 is equal to 1. All 6 trigonometric ratios are obtained for angle 90 degree. Then we can write these 6 trigonometric ratios together. First you have to note down. Okay. First one is Sine 90 degree, it is equal to 1. Second one is cos 90 degree, it is equal to 0. Third one is tan 90 degree, it is equal to infinite. The next three trigonometric ratios I am writing here are the opposite of each trigonometric ratio respectively. Then what is the opposite of sine? It is opposite of cosec. Then I am writing cosec 90 is equal to 1. Then sec 90. Sec 90 is equal to infinite. Then cot 90 and cot 90 is equal to 0. These are trigonometric ratios for angle 90 degree, and here we have obtained as trigonometric ratios for 0 degree. You note down. Today we have discussed trigonometric ratios for two types of angle, 0 degree and 90 degree. First you have to note down all these conditions, and you have to understand these trigonometric ratios at home. If you have any doubt, you can ask by commenting in comment box. Or next trigonometric ratios for different angles we will discuss in later class tomorrow. Okay, thank you.